Hi everyone. Today we're going to learn more about trigonometry. We're going to learn about sine and cosine and tangent, which are trigonometric ratios, and those are going to help us solve angle of elevation, angle of depression problems. So we're going to do word problems today where we have to draw pictures, we have to use concepts of sine, cosine, and tangent to figure out missing side lengths. So let's get started with our warm-up. I want us to practice special right triangles. So I know this triangle is a special right triangle. If it doesn't say there's the right angle, should put that in there. Okay, I want you to find the exact lengths of x and y. Pause the video. When you are ready, we'll take a look at the answers. Okay, so hopefully you remembered 45, 45, 90 triangle. The two legs are the same. So x has to be 8. And then to get from the leg to the hypotenuse, you multiply by the square root of 2. So we leave it as 8 times the square root of 2. Okay, don't make it a decimal, especially if it says exactly. Exactly does not want a decimal. Now today we're going to deal with all of the other right triangles. What happens when it's not a 45, 45, 90 or a 30, 60, 90 triangle? So today we're going to deal with the concepts of sine and cosine and tangent and what's the angle of elevation or depression. And each one of these is going to be helpful. And we're going to learn that we make a picture, okay, it becomes a right triangle, we can use trigonometry. So what do we remember about sine and cosine and tangent? Pause the video. Start by writing down what you remember, and then we can fill in the missing details. Maybe you forgot about cosine, but you know a whole lot about sine. Maybe you don't remember much about any of them, but what do you remember first? So let's take a look at each one of them, and let's make sure we have a clear understanding of what each one tells us. So if the angle we're looking at is at the base, we call this angle alpha, then sine is the height ratio. It's y over h. And I'm going to use y purposefully, okay, because y is the height of it's a height coordinate. So sine of alpha equals y over h. The ratio. So y divided by h. Now cosine, still looking at alpha, is the base ratio. So it's the adjacent over the hypotenuse. So cosine of alpha equals x over h. And once again, I'm using x specifically because x is a horizontal distance and h is my hypotenuse. Now, tangent is the slope ratio. So tangent is the opposite over the adjacent. Opposite over the adjacent. Change in y over change in x. Okay, it's the slope of this hypotenuse. And that's going to be really important when we get to circle trigonometry, understanding that tangent is a slope. So now some of you are saying, Mr. Minowitz, we learned a long time ago this phrase, SOHCAHTOA, where sine is the opposite leg over the hypotenuse and cosine is the adjacent over the hypotenuse and tangent is the opposite over the adjacent. And I agree. I also want us to understand that sine is the height ratio and cosine is the base ratio. And if you remember SOHCAHTOA, that's going to help us a lot. Now, please be sure that you spell it correctly, because I've seen many mistakes where Someone spells so, S-O-A. I don't know. But you spell correctly, it's going to go a lot towards helping us get it right. Now, we may be asked to find the sine of A, or the cosine of A, or the tangent of A, which is telling us what's the ratio. It's not asking us to find angle A. It says don't look at angle B. I don't care about angle B. So from this triangle, here are a few hints that I like to always do. Okay, I like to label my starting angle or make sure I know which angle I'm looking at. I like to label the sides. So if I'm looking at A, from A, the hypotenuse is always the long side. The opposite's always the across, and the adjacent means next to. If you label them, you will get it right more often. I also like to write SOHCAHTOA on my paper, or have it in my mind. Okay, now if it asks for sine of A, okay, it wants opposite over hypotenuse. So the sine of A is 20 over 29. Wants me to do the same thing with cosine and tangent, I can do that. Cosine's adjacent over hypotenuse. Tangent of A is opposite over adjacent, 20 over 21. Okay, be careful. Remember which ratio am I looking for? Sine is opposite over hypotenuse. I know what the two numbers. I know which fraction I have to make, and I do it well. Now, a situation may also say, what's the angle of elevation? Or the angle of elevation is 27 degrees. Okay, now whenever we say angle of elevation or angle of depression, always think of it as someone's looking straight ahead, and elevation is the angle above their glance, and the angle of depression is below their glance. And if you ever forget that, remember Squidward likes to look up and he likes to look down. Okay, always from a horizontal. From the horizontal. So when word problems say, hey, the angle of depression, it means you're looking straight ahead, and what's the angle downward? Now here's some helpful hints. Okay, when you given a word problem, you draw the picture. Most of you can solve a trigonometry problem when I just give you the triangle. Draw the triangle first. Label the triangle, the opposite, the adjacent, the hypotenuse. Is there any side length that they give us? Is there any angles? Fill in all of the details, and you got this. Now, the new detail is that the angle of elevation and angle of depression are always from a horizontal. And we're going to see what that looks like in some word problems. And you're always going to see, I'm going to draw the picture. So a problem may ask us to find the missing side length. So it says sonar on a salvage boat locates an object at a downward angle of depression of 50 degrees, and a distance of 510 meters, as shown in the drawing. They give us the drawing. So the angle of depression is 50 degrees, the diagonal distance is 510 meters, and it wants how far below. So it wants the depth. So draw the picture, label the sides, and then we're going to figure out which ratio we got to use. Okay, now you don't need to draw the pretty boat or the shark, but the triangle is going to be really helpful. Labeling it's going to be really helpful. Okay, I need to find D, and I know the hypotenuse. So I don't know the opposite, but I know the hypotenuse. So I know which ratio I'm looking for, a ratio with opposite and hypotenuse. So we're going to do a sine problem. So the sine of 50 degrees, because we know the angle, is opposite over hypotenuse, d over 510. We're going to solve for d. Okay, don't be worried about sine of 50 degrees. Sine of 50 degrees is a decimal. So we multiply both sides by 510, and then we put this in the calculator. This is the exact answer, but it probably wants a decimal. Okay, so 510 times sine of 50. Make sure your calculator is in degree mode, and we get an answer of 390.68 meters. So now, it is your turn. You wonder how tall a grain silo is. You walk 60 feet from the silo and find that the angle of elevation is 38 degrees. Okay. We want to know how tall is the silo without the roof. Pause the video, try it out, see if you can do this, and we'll check it momentarily. Okay, you tried it out. Hopefully you got the correct ratio, you draw the picture, and calculations are good. Now, if you got this answer, I give you a ton of credit. Okay, we see we have the opposite over the adjacent, which means we got to use tangent. We got to multiply both sides by 60. And if you got 46.88, you found this distance. You might have just forgot to add the 5.25 feet, which is a really, really complicated part of this problem. Okay, for just the triangle part, this height of the triangle is 46.88 feet. So you did great. Now, 5'3" is 5¼ feet, so we'd have to add that to get the full height. But if you got 46.88, you know what you're doing with triangles. Now we'll take and try one more. Now you got to do the picture this time. For safety in climbing, a ladder against a wall. The ladder should ideally make an angle of 75 degrees with the ground. So angle of elevation is 75 degrees. The ladder is 12 foot long. How far from the wall should you put the base of the ladder? So pause the video, draw the picture, figure out which ratio you're using, and then solve for that distance. Okay, you tried it out. Let's see how we did. So 12-foot ladder, the 12 foot's the diagonal because the ladder's on a diagonal. My angle of elevation is 75 degrees, and it wants the base. It doesn't want the height. If you found the height, there'd be a different ratio we needed to use. Okay, now we should label this the adjacent and the hypotenuse, the opposite. So I need adjacent and hypotenuse. That's why I used cosine. I solve for b by multiplying by 12 on both sides and get 3.11 feet. Now let's say you accidentally solve for the height, which I'll call y. Okay, if you wanted to know how far up the wall the ladder touches, we could have done the opposite over the hypotenuse and said, well, we have the sine of 75 equals y over 12, and then y equals 12 sine 75. So if you did that, then great, you correctly found the height up on the wall that the ladder's touching. Now what you need to do is make sure you read and correctly answer what the question's asking. So in this lesson, we learned the ratios sine, cosine, and tangent. We learned about angle of elevation and angle of depression. We learned we should draw the picture, and then we can use these ratios to find missing side lengths.